Hello everyone. In today's session, we are going to learn how to use helpers.tpl in Helm with example. There are two steps. In this article, we are going to cover use of Helm template file helpers.tpl with example. The helpers.tpl file in Helm is a powerful tool designed to assist in the customization and organization of Helm charts. It contains reusable templates, helper functions, and share values. This file allows you to define common logic and configurations, making your charts more modular and maintainable. So this is our table of contents. First, we will see prerequisites, then purpose of helpers .tpl in Helm chart. Next is troubleshooting and pitfalls, then use cases and best practices of helpers.tpl, and finally the conclusion. So let's see the prerequisites. First, you should have AWS account with Ubuntu instance running, then Minikube and kubectl installs. Also, you should have Helm installed. You can follow the official documentation mentioned here, or you can watch our previous video. So I already have my Ubuntu instance and Minikube and kubectl and Helm installed. So let's see the purpose of helpers.tpl in Helm chart. The primary purpose of helpers.tpl file in Helm is to serve as a centralized utility for code reuse and configuration management. It allows developers to define reusable YAML snippets, enabling the creation of standardized configurations across a Helm chart. So the developers can define reusable YAML snippets and encapsulated helpers function in this file. These shared components can then be used across multiple templates. Additionally, it facilitates the encapsulation of helper functions, providing the means to streamline repetitive tasks and enhance the modularity of the chart. Helpers.tpl allows for the setting of default values for variables, ensuring consistent and sensible configuration, while allowing flexibility for users to customize as needed. In essence, the file plays a pivotal role in maintaining code clarity, reducing redundancy, and promoting best practices in Helm chart development. So when developers define variables in Helm charts, helpers.tpl becomes a central location where default values can be specified. This is especially useful when you don't provide specific values for these variables. That time the default values strikes in helpers.tpl. Now let's see the example for it. First, create a chart. You can give any name to your chart. The command is helm create my chart. Now our chart is created, which is named as my chart. Now open the my chart directory using cd my chart command. Open the values.yaml file. Command is nano values.yaml. Then add the environment variable section below the service section into it. So this is the environment variable section. Here the environment variables key represents the list of environment variables. Then name gives the name of environment variables. Here it is db host and db port. Same as for value, the value assigned to environment variable. Here it is localhost and 3306. So let's copy it and paste it in the values.yaml. Here we copied it right below the service part. Now let's save it. Press Ctrl plus X, then Shift plus Y, hit enter. Now open the template directory using cd templates command. Then open the -helpers.tpl file and define the environment variables in it. The command is nano-helpers.tpl. We are going to copy this part. We are going to paste it below the selector labels. Here, define helper function for environment variables. This is a comment in Helm templates. Comments are ignored during rendering and are just for human readability. Then define myChat.environment variables. This line defines the start of Helm template. It is named myChat.environment variables. The hyphen after the opening curly braces is used to trim the white space, meaning that leading and trailing white space in the template will be removed. Then next line is hyphen range dot values dot environment variables. The line starts a loop that iterates over the values in the values dot environment variables. The hyphen refers the dot refers the current context, which in this case is assumed to be the context of the Helm chart. Is name colon, then under curly braces dot name. Inside the loop, this line prints the name property of each item in the environment variables array. Next is value under the curly bracket dot values type, then quote. Similarly, this line prints the value property of each item in the environment variables array and uses the quote function to ensure proper quoting of the value. Then this end statement marks the end of the loop, and this end marks the end of the template definition. To save the modification, press Ctrl plus X, Shift plus 5 and hit enter. So let's save it. Then open the deployment.yaml file using nano deployment.yaml command. Here our deployment.yaml file is open. Now we are going to add environment variable section in it into the container box. Copy it. In container, post it after the ports section and before the liveness probe. Let's save the modification using Ctrl plus X, then Shift plus Y, hit enter. To save the modification, press Ctrl plus X, Shift plus Y and hit enter. Now exit the directories. For this we are going to use cd command. Then we will run the helm template command, which is helm template my chart. So first exit the directories using cd command. Then run the template command. Here you can see the output. So this is our deployment file right over here. And as you can see, the environment section is printed correctly, having name, db host and db port with values localhost and 3306 respectively. Loop is iterated successfully. You can see the output here in the image also. So as you can see, the environment block is generated by the mychart.env template from helpers.tpl. It includes the db host and db port environment variables defined in values.yaml. The output demonstrates how Helm processes the templates and values to generate Kubernetes manifest files. In this example, helpers.tpl defines a template named mychart.env that generates the env block based on the environment variable specified in the values.yaml. Then deployment.yaml includes this template using include mychart.env, and values.yaml contains the environment variables dbhost and dbport in this case. Now let's see the another example. Create a Helm chart, which is Helm create node app. Our chart is created, which is named node app. You can give any name to your chart. Then open the node app directory using cd node app command. Now let's open the values.yaml file using nano values.yaml command. Our file is open. Then we will modify it as shown below. We are going to place our own value name colon devsint under the resource and before the auto scaling section. Now to save the modification, press Ctrl plus X, then Shift plus 1 and hit enter. Now open the templates directory using cd templates command. Now let's modify the helpers.tpl using the following command. The command is nano hyphen underscore helpers.tpl. We are going to copy the code and paste it right below the expand the name of the chart section. Here, define the service name line. This line starts the definition of the Helm template. The hyphen after the opening curly braces is used to trim white spaces. Then hyphen default dot chart dot name dot values dot name pipe trim 63. Then again pipe trim suffix hyphen underscore. This line contains the logic for generating the service name. Now let's break down each part. The default dot chart name dot values name. This uses the default function to select the first non-empty value. Then it checks if the values dot name is provided or not, and if so, uses the value. Otherwise, it falls back to dot chart dot name. Then trunk 63. This truncates the resulting name to a maximum number of 63 characters. Kubernetes has a limit of 63 characters for service names. Then trim suffix underscore hyphen. This trims any trailing hyphens from the name. And lastly, the end statement marks the end of the template definition. Let's save the modification using Ctrl plus X, Shift plus Y, hit enter. Now modify the deployment.yaml file using following command. The command is nano deployment.yaml. Now let's modify the deployment file. We are going to put this line in the metadata section. So let's copy it. The metadata section is right below the kind in the deployment.yaml file. Here you can see it in the image. Let's save the modification using Ctrl plus X, then Shift plus Y, enter. Now exit the directories using cd command. Then run the Helm template command. Again, Helm template node app. So first, let's exit the directories using cd command. Then we will run the template command. So let's see our deployment.yaml file. Here it is. Here you can see in metadata, the name DevOps int is printed. You can see the image of this output. The overall purpose of this template is to create a dynamically generated service name based on certain conditions. It provides flexibility for users to either accept the default chart name or specify a custom name in their values.yaml file. We specified the name as DevOps int. You can specify any name. The resulting name is then adjusted to meet the Kubernetes naming requirements. Now let's see the troubleshooting and pitfalls of helpers.tpl. When working with the underscore helpers.tpl file in Helm, it's important to be aware of potential troubleshooting scenarios and common pitfalls that developers may encounter. First is one common issue is the misplacement of the underscore helpers.tpl file within the chart directory. Ensure that it resides in the correct location for Helm to recognize and process it. So ensuring that the helpers.tpl file is placed in the correct location within the chart directory is crucial for Helm to recognize and process it during chart rendering. Another potential pitfall involves naming conflicts. Since the helpers.tpl file is shared across variable templates, it's crucial to use unique names for functions and variables to avoid unintended overrides or clashes. Given that helpers.tpl is shared across various templates, it's important to use unique names for functions and variables to prevent the unintended overrides or clashes. This helps maintain the modularity and isolation of functionality. Furthermore, if helpers function are not properly defined or if there are syntax errors within the helpers.tpl file, it may lead to issue during chart rendering. Regularly review and test the context of the file to catch and address such errors early in the development process. So you need to take care to properly define the helpers function and avoid the syntax error within the helpers.tpl file. You can do it by regularly reviewing and testing the contents of the file that can catch and address such issue early in the development process. Additionally, when setting default values for variables, be mindful of potential conflicts with user provided values. Helm allows users to override default values, so it's essential to define default configurations that gracefully accommodate user automation without causing unintended side effects. Now the last is in troubleshooting. Inspecting Helm's debug output can provide valuable insights into potential issues within the helpers.tpl file. Enabling Helm's debug mode helps developers trace and diagnose problems effectively. So these are the pitfalls and troubleshootings in helpers function. Now let's see the use cases of helpers.tpl in Helm chart. First is standardized labels. It defines standardized labels for Kubernetes resources in helpers.tpl. Then it ensures consistency across your Helm chart, making it easier to identify the and manage resources. So in the helpers.tpl file, you can define standardized labels for Kubernetes resources. Labels are labels are key value pairs that are attached to Kubernetes objects, providing metadata. And by defining standardized labels in helpers.tpl, you ensure consistency across your Helm chart. The standardized labels can include information such as application name, environment variables, type, or any other relevant metadata. Next is default resource request. It set default resource request and limits for containers in helpers.tpl. Then improve the out-of-box performance of the Helm chart with sensible resource configuration. So in helpers.tpl, you can set default resources request and limits for containers. This allows you to specify the amount of CPU and memory resources that a container requires or is limited to. By defining default values for your resource request and limits. You enhance the out-of-box performance of your Helm chart, and this ensures that your application is allocated an appropriate amount of resources by default. Third is centralized namespace handling. The centralized namespace handling logic in helpers.tpl, it gives streamlined deployment to different namespaces by managing namespace related configurations in one place. Now in helpers.tpl, you can centralize namespace handling logic. This involves managing configurations related to namespace in one place. This can include setting default namespaces, allowing users to override namespace values, and ensuring that all resources are deployed to the correct namespace. Fourth is reusable annotation. It creates reusable annotation for Kubernetes resources using underscore helpers.tpl file, then promote consistency by applying common annotation to various resources without duplicating the code. So annotations are metadata attached to Kubernetes objects, providing additional information. In helpers.tpl, you can create reusable annotations for Kubernetes resources. This promotes consistency by applying common annotations to various resources without duplicating the code. It can include details such as build information, contract information, or any other relevant metadata. Now let's see the best practices of helpers.tpl in Helm chart. First best practice is clear naming. So use of clear and straightforward names for variables and functions in the helpers.tpl file. And it is a fundamental best practice in software development. An option for names that directly convey their purpose to make the code easy to understand. This involves choosing names that directly convey the purpose of the variables and functions. So, for example, instead of generic names like X or temp, use names like default app name or generate labels that clearly indicate their role in the chart. Second best practice is concise comments. It adds concise comments to explain the purpose of each section and variable or function. So adding concise comments is crucial for enhancing code readability and understanding. It keeps comments up to date with any changes to ensure they remain helpful. So you need to remember to update comments whenever the code changes to ensure they remain accurate and helpful. Third is logical organization. Organize the helpers.tpl file logically, grouping related functions and variables. Create separate sections for snippets, functions, and default values for easy navigation. Logical organization is essential for maintaining a clean and readable helpers.tpl file. Group the related functions and variables together and create separate sections for different purposes. So for example, you might have sections for environment variables, default values, and helper functions. This logical structure makes it easy for developers to navigate the file and find what they need. Fourth is consistent formatting. Maintain consistent formatting such as indentation and spacing throughout the file. Consistency enhances readability and makes the code visually cohesive. Consistent formatting, including indentation, spacing, and other stylistic choices, is critical for code readability. Consistent formatting also aids collaboration as developers can quickly adapt to the established style. Fifth is documentation reference. If there's extensive documentation for the Helm chart, Include a reference or link in the helpers.tpl file. These self-developers quickly find more detailed information about the chart structure and behavior. Conclusion. In conclusion, the helpers.tpl file in Helm proves to be a valuable asset for enhancing the efficiency and maintainability of Helm charts. By allowing developers to create reusable snippets, define helper functions, and set default values for variables, this utility file promotes a modular and standardized approach to Kubernetes deployments. As a central hub for code reuse and configuration management, helpers.tpl is a essential tool for Helm chart creators seeking to optimize their workflow and build robust and scalable applications. Thank you.